So we're going to begin talking about graphing polynomial functions, which is really bringing a lot of these skills we've been talking about all together. Before we do that, we need to talk about a few of the little patterns and rules that make reading the polynomials a lot easier. Okay, so polynomial functions, a couple of vocabulary words that you've probably heard before, and I'm just going to say them again here. The degree, in the case that we're using here, is just going to be the highest exponent listed in the polynomial. And that's because we're only using one variable, so you can really just look at the highest exponent. Okay? I call that term the bus driver because it dictates most of the shape, minus a few small pieces. The other shapes are going to be determined using multiplicity, which is going to be in the factored form. Degree is going to come from the original form, the standard form. Multiplicity is going to come from the factored form. Okay, so make sure you don't get those two mixed up. Okay, degree, original form, multiplicity, factored form. Okay, now each factor is going to have a multiplicity in the factored form, and the sum of the multiplicities should always come out to be the degree itself of that polynomial. Okay, all right, so then a couple of little shape examples here so that you can see the patterns that we're working with. Okay, so your degree, of course, is either going to be even or odd, right? Whichever highest power you've got. So let's look at the pattern on the odd degrees here. And when I say pattern, I'm talking about the endpoints. Okay, so you'll notice that when I'm graphing x to the 1, something with x to the 3, the dot, dot, dot just means there's more polynomial stuff with that, right? Dot, 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 more polynomial stuff with that. But when it's an odd power, x to the 1, x to the 3, x to the 5, I want you to notice that every time the endpoints are opposite, right? See, down then up, up, and then down. That's going to happen because as x gets large on either side, the bus driver's term is going to preserve the negative. Okay, so a very large negative, very large positive, and then it'll stay that way. However, if you have an even degree, right, things with a squared or a fourth power or a sixth power or so on as their highest power, then no matter which side x gets large on, the degrees tend to get rid of negatives and keep whatever sign the bus driver has, right? So in this case, I notice I have a positive x squared, so both of my ends are up being positive, and they match, right? Even degrees always match in direction. Notice here, both of them go down, and that's because it is even, they do match, but the bus driver himself is negative, so they're going to both go downward, right? Here, x to the 6 being positive, they both go up. Okay, so there's actually a pattern to this, right? If I notice that I have an odd degree, I already know that my endpoints are going to be opposite. Normally, those would be oriented down, then up. However, if it's reflected, like with a negative in front, it will go from up to down instead, right? Like that one. Even degrees, the ends always match. Normally, they would both go up, up. But if they have a reflection, like a negative on the bus driver, then they'll both go down, down. Okay? So one of the things you'll want to look at from standard form before we do any factoring is, what is the degree, meaning what's the exponent on the bus driver? And we'll also be interested in the sign of the bus driver, whether he's positive or negative, because the bus driver being negative will reflect it, and the bus driver being positive will not reflect it. Okay? So there's a huge pattern that we need to see from that. Another pattern that's going to help us out is the fact that you'll notice that x to the 1 here doesn't have any turns whatsoever, right? X to the 3 has 2 turns. X to the 5 has 1, 2, 3, 4 turns. X to the 2, 1 turn. X to the 4, 1, 2, 3. X to the 6, 1, 2, 3, 4, 5. So you should see a pattern starting to form here, right? The maximum number of turns, okay, number of turns maximum, is always going to be whatever the degree is minus 1, Okay, so that's another pattern that can help us make sure that we have an appropriate shape in our graph. Okay, so those are the patterns that we need to be looking for, and the more you do these things, the more they'll just start coming to you. Okay, so let's do an example. Here's one of the polynomials that we factored in the last lecture, right? X to the third plus 11x squared plus 35x plus 25. We factored that into x plus 1 times x plus 5 squared. Okay, so first thing I notice is the bus driver in the standard form. Remember, the degree comes from the standard form, and that he's positive. Since the degree is 3, that's an odd degree. I know that they're opposite. And since it's positive, I know that it's going to go from down to up. It's going to increase. Okay? Next thing I notice is in the factored form, I have my x-intercepts of -1 and -5. The -1 has a multiplicity of 1, and the -5 has a multiplicity of 2. Okay? Now the pattern to notice with this is, like I was saying before, we're actually going to get some shape information from the multiplicities. Okay? So whatever exponent the multiplicity is, that's the shape that you can expect the polynomial to act in a really small little neighborhood around the x-intercept that that factor is talking about. This is what I mean. X plus 1 is talking about the intercept, x equals -1. And since it's x plus 1 to the 1 power, x to the 1 power is like a line. Okay? And so what I want you to notice is at the -1 intercept right here, you'll notice that my shape is rather straight, like a line. It goes through the axis there. Okay? So then the next part of this to notice is I do have the x plus 5 factor, right? Goes with the x equals -5 x-intercept. The multiplicity is 2 on that one. Okay? So then the shape really close to that x-intercept is going to be that of just like an x squared, right? An x squared has a parabolic type of shape. Okay? But just in a small neighborhood. So notice, right? Just in a small neighborhood here, I get this little parabola looking shape right here, right? So then let's put all the information together. I start with the degree and the endpoints. So I know I'm going to start down here, and then I begin to draw, right? I know I'm supposed to have that parabolic shape and bounce off of -5 because of the multiplicity, so I do that. And then I continue drawing, and I turn again. And the reason I turn here is because I know it has to go through x equals -1. It's a fact that I have found that x-intercept. So I turn just so I can hit that intercept. But then I go through like a line because of the multiplicity, and then I just continue on because I have no more x-intercepts. Also, another little side note that can help you in these graphs, I noticed from the standard form that the y-intercept is 25. Remember, y-intercept is when x is 0. So when all of these are 0, I'm just going to be left with that number 25. And it actually worked out really well, right? I labeled 25 on the axis. Now, of course, the scale there isn't exactly the same as the x-axis, and that's not important for these kind of graphs. We're trying to get a quick 80% graph here that's pretty accurate for the x-intercepts and the major pieces of the shape here. Notice I don't know exactly how low this piece is, and that's okay. That's a question for a calculus class. Okay. Now, 3 more examples from the polynomials that we did last time, and a little bit a different one as well. Right? These 2 are from stuff we factored before, and this one was just something given to us already in factored form. So let's take a look at these here first, right? So this is the point in which one of these problems when you would start putting together your information to graph, right? So let's take a look at the different pieces of information. Okay, the first thing I'm noticing, right, is the bus driver here. My degree is 4, and the bus driver's positive. Since the degree is even and it's not reflected, I know that my endpoints are going to be up, up. Okay? Since my endpoints are going to be up, up, that'll help me begin and end my graph later. Okay? The next thing that I'm going to take note of, are my x-intercepts and their multiplicities, right? My intercepts here are x equals 4, multiplicity 1, x equals negative 3, multiplicity 1, x equals 2, multiplicity 1, and x equals negative 2, also multiplicity 1, right? Okay, so let's put our graph together here. I'm going to need an x and y axis. Okay, I've got a couple of negatives, a couple of positives, should be pretty evenly spaced. I'll just put this right through the middle. And I need to go 4 in the positive direction here. And at least 3 in the negative one, right? So 3, 2, 3. I'll go ahead and do 4 just to be balanced. Doesn't matter, it's fine. Okay, so then at this point, I can start marking down some of my information. I know that my intercepts are points on my graph. So let's start marking those, right? I've got 2 and 4. So that's going to be here and here. Those are intercepts. And then also negative 2 and negative 3. So that's going to be here and here. So I'll be looking out for those points. Okay? Now, as I'm drawing, I'm going to actively be looking at the multiplicities. Now, in this example, they're all 1, right? Which means x to the 1 every time, which means they're all going to act like lines locally. Okay? So I start in an upward direction, and I should end in an upward direction. So I'm starting in the upward direction here, and I'm just going to draw. I'm approaching an intercept, and I go through like a line. Once I get to here, I want to turn so that I can hit my next x-intercept. Right? So I turn, I go through like a line again. Okay? Now don't let this fool you. I know you're thinking, hey, he just drew a parabola. No, I didn't. I went through 2 different intercepts, line and line. Okay? The curve was just because I had to get to the next one, which actually I'm going to have to do again, right? I'm going to have to, at some point, turn so that I can get down to this next x-intercept here. So I'll do this. Yeah, maybe a little bit more like this, right? And again, multiplicity of 1. So I'll go through like a line. I've got to turn one more time because I've got to hit that next intercept. So I'll do this. Go through like a line. And then continue on. And notice I didn't even have to think about that last endpoint. It's more like a check, right? The endpoints are both going up. Okay? Now, is this thing really that high up? Are these things really that down low? You won't know unless you plug in a bunch more points or study a little bit of calculus. Okay? We can label one other thing, right? The y-intercept is 48 because that's what happens when x is 0. And you'll notice this is right about there, right? This is right about where 48 would be, ish, right? If the scale was off. I'm not off, but if the scale was disproportionate, like x and y disproportionate. Okay, let's do it again on the next one. Take a look at the bus driver, right? Negative 3x to the 3. So then at this point, I'm noticing that it's a degree 3, and then it's negative. Notice I don't care about the actual 3 in the front of the x. I only care about the exponent and the sign. So I have a negative degree 3. What is this telling me about the endpoint? My endpoints are going to be up, then down. Because remember, normally things want to increase when they are odd like that. But it's negative, so it's been reflected. Okay? So then it'll be decreasing from up to down. All right, now let's take a look at the multiplicities here. I've got my x-intercepts, -1, 3, and 2/3. And again, they're all multiplicity 1, right? All multiplicity 1s here. So all three of those are going to act like lines also. Okay, so let's get a grid going on here. Okay, so then I need to go at least 3 in this direction. And at least 1 in that direction. I'll probably be able to squeeze in 2. Yeah, why not? Okay, and again, notice I'm not really worrying about the scale on my y-axis because we'll fill in whatever information we need later for that. Okay, now my intercepts. -1 is right here. 3, of course, is right here. And 2/3, well, I'll just get that right about where I think it is, you know, between 0 and 1, but not a little bit past half, right? That's there. All right. Now, the endpoints are supposed to be from up to down. So that's easy. I'll start up here, and then I'll hit my first intercept, and then I'll have to turn, right? Go through, and then I'll have to turn again. So it should do something like this. Like that. Right? And then the only other piece of information like before that we could label is we notice that -6 is our y-intercept. And you can see, again, that does make sense for where this thing is going through there. Now, does this thing actually bottom out on that side or this side? You won't know unless you actually plug in more points. Okay? Okay, now, look at this bottom one here. On the bottom one here, it's already in factored form, and I wasn't given a standard form, which, looking at the factors themselves, I'm kind of, being thankful for that particular point. But I still need some information from the standard form, right? The helpful standard form would have been a couple of pieces of information. Well, that's okay. I'm also remembering, hey, wait a minute. The degree was just the sum of the multiplicities, right? So I'm going to take a look at my intercepts and multiplicities here first, and then I'll use that to get my degree information. So my intercepts here are -2, 5, and -4. And then I'm noticing a multiplicity of 3 here, a multiplicity of 1 for the 5, and a multiplicity of 2 for the -4. So if I sum these up, 3 plus 1 plus 2, my degree would have to be 6. All right. Well, the degree is an even number, so I know that the endpoints have to match. They're either both up or both down, but I got to know which one of those it is. And then I notice all of my x's are positive. So if I were to multiply those out, I'd get your plain old x to the 6th times -2. So my bus driver is actually the -2x to the 6th, right? The -2 happens to be there, and there's no other numbers multiplying by x. So the first term would have to be -2x to the 6th. It is negative. And even degree. So my ends are going to have to be down, down. All right. So let's draw this guy out. So right here, I'm going to put my grid And let's see, I need to go, let's say 5 in each direction. 2, 3, 4, 5. 1, 2, 3, 4, 5. Forgive me if my spacing's off. You know, I'm only human. I'm just trying to get a rough graph here anyway, just so we can understand the shape. Okay, let's look at our intercepts. -2, that's here. +5, that's over here. And -4, that's right here. Okay? Now my endpoints are supposed to be down, down. So I'm going to start from down here. And then I'm going to approach that first intercept. But that first intercept at -4 had a multiplicity of 2. So I'm not going to go through it. Remember, x squared, multiplicity of 2, that's a parabola shape. So I'm going to approach it and bounce off of it like this. I'm going to bounce off of it. That's a parabola shape in the neighborhood of -4. I still have to turn again, though, because I need to approach my next point. So it's going to turn again right here and approach the -2 intercept. Now, careful. The -2 intercept had a multiplicity of 3. Now remember, x to the 3 had that swirly shape, right? It goes from down to up, like an x to the 3. It flattens out in the middle and then continues going up. So that's what I'm going to do right here at this intercept. I'm going to approach, let me go further down here to make this easier. I'm going to go down, and when I come up, I'm going to approach, I'm going to flatten out right here, and then I'm going to pick back up again, right? So technically there's 2 very tiny turns here. It's flattening out and then picking up again. I'm going to go way high up this time, and then I've got to turn so that I can hit this next point way over here. Okay, well, the 5 intercept had a multiplicity of 1. So it's just a plain old going through it like a line, like this. Okay, now it doesn't quite do it justice here with the lopsidedness, but you get the point. It's going to go down here, it's going to go down here. And then if you want that other piece of information to check, you'll actually have to plug in 0 to get your y-intercept here, right? I would have to do -2 times 2 to the 3rd times -5 times 4 squared, right? And you get a very, very large positive number because I've got positive number, and then negative times negative. So it's going to be a very large positive number, but you notice it does actually hit that. Let's see, -40, 80 times 16. So what's that? 1280, I believe. Yeah, 1,280. Very large positive number. Okay. For this next example, I want to work one from beginning to end, using all of the different things that we've been talking about since we started polynomials. So we have a polynomial function, and I want to actually get to the graph of this thing and have a pretty decent shape of it and have all the important points labeled. The first thing that we'll do, just like before, is I'm going to factor it to the best of my ability. That means we may have to employ some division, right? But first, just take a look at it and make sure there's not something that you can do quick for a beginning factorization. This case does actually have one of those, right? You'll notice everything has an x. I could start by just a GCF of x. So let's start that factoring process. We've got x times x to the 4th minus 10x to the 3 plus 28x squared, and then minus 64. Right? So I've already gotten one factor out. Great. So then I'm looking at factoring this inside part here. And it's not going to fit any of my other factoring methods. One, it's 4 terms, so it can't be a trinomial, can't be difference of squares or anything else like that, right? So I'm going to have to just take this on with the synthetic division. Well, remember from last lecture, we talked about how we can factor this, but I need the list of guesses, right? So I'm going to look at the factors of 64 and the factors of 1. Well, it's very nice to have the factors of 1 over here, because it's just going to be the factors of 64 over the 1. Okay, so let's make the list of guesses, right? The list of guesses. The factors of 64, right? 1, 2, 3 doesn't go, 4 goes, 5 doesn't work, 6 doesn't work, 7 doesn't work, but 8 works, right? 8 works, and then 8 times 8 is 64, so I don't have any other unique multiplications after that. I've kind of gone over that hump, so then I can start mirror imaging, right? 4 goes into 64 16 times, 2 goes into 64 32 times, and then of course 64 is its own factor. And then I need the negatives, right? So I'll have -1, -2, -4, -8, -16, -32, -64. Right? So I've got my whole list here now of guesses. And remember, the reason why I got just the whole numbers is because it's over the factors of 1. Right? If there had been another number over here, I would have to divide by the factors of that number as well. But we lucked out on this one, right? It's a good one to factor with. Okay, so we can go through the list and start guessing which ones are really our guy, right? I'm going to cut to the chase. Let's say I've gotten a couple of them wrong, right? We're going to try 4. So I divide 4 into my polynomial here. 1, -10, 28, 0, don't forget because I skipped a power here, -64. Put my 0, draw my line, divide, right? So I add, multiply, add, multiply, add, multiply, get 16, add, 4 times 16 is 64, add, I get 0. Remember, that's our magic we love to see. Okay? Now I'm going to cut to the chase again, right? We'll go through a few more, but the next guess is also 4. It actually happens to work twice. So I'll go ahead and divide that one out too. Put 4 in the box again. Draw a 0 here again. Just go to here. Add, multiply, add, multiply, add, and then multiply -16. Get my 0 again. Okay, so let's write down the factors that we were talking about here, right? The 4 in the box, remember, comes from the factor x minus 4, because that's the number of what the number 4 causes to be 0. And that factor gets used twice, right? And then I've also got this piece right here, which is x squared minus 2x minus 4, which is not factorable with the numbers in the list, right? You'll notice there are not 2 numbers that multiply to -4 that add to -2. I can't factor it old school either. So I'm going to have to resort to the quadratic formula for that one. Okay, so let's write down our full factorization here as far as whole numbers go. I've got x, I've got x minus 4 squared, and I've got this piece right here, which is x squared minus 2x minus 4 left over. Right? So that's where I'm at with just the factorizations. Right? If I'm talking about just factoring, I have to stop here. But I need all of my x-intercepts. I can already read 2 of them, right? I can read the singular ones here. But I also need 2 more x-intercepts from here, because I should have a total of 5 factors, maybe less than that x-intercepts, but a total of 5 factors. And I've only found 3, right? X and x minus 4 twice is 3. So I'm going to get my other two intercepts out of that guy right there. Right? So let's block this off. Just sort of separate that out. Because we did those divisions already to get this factorization. Right? So I've got my x-intercepts here from these two. Let's go ahead and write those down. I've got x equals 0 from this factor. And I've got x equals 4 from that factor. And this one has a multiplicity of 1. And 4 has a multiplicity of 2. Right? Makes sense because the 4 got used twice, right? Okay, so next I'll need to solve this. X squared minus 2x minus 4 equals 0, which is going to require the quadratic formula. Right? So I'll just solve that. X equals negative b plus minus square root b squared minus 4ac all over 2a. So then I've got x equals, let's see, 2 plus or minus, negative 2 squared is 4, double negative plus 16, so I've got the square root of 20 all over 2. And the square root of 20 I can simplify as 4 square root of 5. Whoops, made a mistake. It's not 4, is it? Square root of 4. 2 square root of 5. 2. And notice I can simplify that because I can reduce both fractions. And remember, you have to be able to do both. 2 over 2 is 1. 2 over 2 is also 1. So I'm getting two more intercepts here. I'm getting x is 1 plus the square root of 5. And I'm getting x is equal to 1 minus the square root of 5. Since we are going to use these for graphing, let's go ahead and write down the decimals for these, right? The decimals for 1 plus the square root of 5 is going to be 3.236. And for 1 minus the square root of 5, it's negative 1.236. Right? So I've got those two intercepts. Those two came from a quadratic, which is x squared, right? It came from this piece right here. That means that I had two multiplicities left to hand out. They're each going to get one, right? Each of these is going to be multiplicity 1. Remember, the multiplicities should add up to the degree. And now we've gotten to all of our intercepts and factors. It's time to start talking about that information. Let's double check. Our bus driver from the original problem is x to the 5th. He is positive and he is odd. That means that my endpoints are going to have to be down to up, right? Because he's odd and positive, he's going to be increasing, right? Odd is opposite, increasing for the positive. Also, keeping in mind the 5, right? These multiplicities should add up to 5. 1 plus 2 plus 1 plus 1 does in fact equal 5, right? Okay. So then let's get a graph here for this guy. I'm going to draw my axis here. And draw this one here. Let's see, let's go a little bit this way. Yeah, that's good. Okay. Now, I need at least 4 in that direction and just negative 1 there. So let's do 1, 2, 3, 4 in that direction. Right? Because I got the 4 there. All right. And then for this one, let's go just 2 in this direction. 1 and 2. That'll do. Okay, so So then let's put down the intercepts. I've got an intercept through the origin here, 0. I've got an intercept through 4 over here. I've got an intercept through negative 1.2. So that's, give or take somewhere right there. And 3.2-ish. 1, 2, 3.2-ish is give or take somewhere right here. Okay? Now, down up are my endpoints. So I'm going to start here and approach. Right? Everything is multiplicity 1 except for the 4, which is on the end way over here. The one at the very end is multiplicity 2. All the rest are multiplicity 1s. So if I'm starting from the downward direction, I'm going to have to go up through this guy here, come back down through this guy here, go down this way, come back up. Now be careful. These two are really close together and they're different kinds of shapes. I have to go through one of them. Right? I have to go through here, and then I've got to immediately turn. And here's the multiplicity 2. I've got to make a parabola. It's got to bounce. And do this. Right? And then check your endpoints, right? It should have been from down to up, and it is, right? My y-intercept is 0 because I have a 0 for x-intercept. And then you notice this is really small. How do I know it's small? It's just such a quick turnaround, right? That's really the main reason. I don't really know how high or low these are going right now because I didn't do any calculations. I'd have to plug in other numbers, right? Also, do you remember the other pattern that we saw in the very first scene here, which was the number of terms is always 1 less than the degree. We're looking at a degree 5 polynomial, and count the terms. 1, 2, 3, and 4. Right? It's always 1 less than the degree there for that one. Let's see just how good of an approximation this graph is. Okay? Let's take a look at the GeoGebra. Note that the x and y axis I've already placed in the order that we need, just to kind of make it more smooth here. You may have to play around with it a little bit if you're doing this fresh, which is not hard to do. You can easily change the orientation and the size of the axes by doing a graphics view stretch and compress like this. Right? Easy enough. For now, what we want to do is we want to take a look at our function here. Here's the function that we were talking about, right? Y equals x to the 5th minus 10x to the 4th plus 28x to the 3rd minus 64x. Let's take a look. Looks a lot like the thing we drew, right? Really peak here, trough here, and then we've got this quick turnaround over here just like we saw, and then it bounces on the 4, right? And here's another cool thing. Notice I didn't actually have to type it in factored form. I just typed in the function, right? Something that this thing can do also is it can actually calculate the roots, which are the x-intercepts. So all I have to do is click on the function there, and notice it automatically calculates those points for us. And of course, these are the points that we already expect, right? We had the 0 that we talked about, and the 4 that was easy to get from our factoring. And then the ones with the formula that we saw, the negative 1.2 and the 3.2 that came from the quadratic formula. Take another real quick look at the graph here. I've put these two here to kind of emphasize to you how this is looking. Take a look around point A right here, which is the negative 1.236, right? That's the 1 minus square root of 5, which is right here. See, I've labeled it in red a little bit, okay? Look at it, it looks very, very straight, right? That's what a multiplicity 1 does to a neighborhood. I'm in this neighborhood around this point right here. It's very, very straight because of the multiplicity being 1. Okay? Now at the same time, since we're talking about that, let's look over here. The multiplicity 2 on the 4 here, right? Should be a parabola.
If I click that on, you'll notice it's very, the little red region here. And that's exactly what's happening. I'm getting this multiplicity where it's just going to bounce. It's barely going to touch this point. It's not going to go through the axis. And then just keep on going upwards there. Okay. All right. So that is a very decent approximation that we drew. Again, notice the y scaling is off, and there's really not a good way using just the algebra to get these points right here. Not a fun way anyway. Those are more for calculus.
For this last example, I want to talk about going in reverse. So we've been handed a graph with information and asked to turn it into a polynomial function. Okay? Now, depending on the instructions, you may or may not have to multiply it out. Most of the time, I don't make my class multiply it out so that I can make the pieces more complicated without actually making them take a lot of time. If it's like a test problem or something like that. But it's just up to who's ever giving the question, really. But in this case, we're not going to have to multiply it out. We're going to leave it in factored form, right? And these are actually not much different than the problem we did in the last lecture, where if you were given the x-intercepts, you can build the factored form very easily, right? And it's the same thing here. Start with just the x-intercepts. I see it goes through -6, -3, and +3. So I know that I need to have factors here that are x plus 6, x plus 3, and x minus 3. Then I go back through and look at their multiplicities, right? This one's going through straight like a line, so I'm going to leave x plus 6 to the 1 power. -3, however, it bounces like a parabola, so I'm going to need this one to be squared, the x plus 3 to be squared. And then lastly, for the +3, it's swirling through, not just straight, but it's actually bending flat and then increasing again downward, right? So that one's going to be to the 3rd power. Right? It's like a cubic. All right, well, let's double check a couple of things. How many turns does the graph have? Right? 1, 2, 3, 4, 5 turns, which means it would have to at least be a degree 6 polynomial. Well, add up the multiplicities. 1 plus 2 plus 3 does in fact equal 6. This is going to be a degree 6 polynomial. Okay, now there's one more piece of information here. Kind of two, but really one. First of all, notice it is pointing downward, right? They are matching, which is supposed to when it's even, but they're pointing downward. So this had better have a negative somewhere in it. All of my x's are positive here, so it's going to need a negative in order to have that reflected downward correctness. But also, we know where the y-intercept is, okay? So right now, if you were to plug in 0 for x, right? If I were to plug in 0 for x, f of 0 here, I would have 6 times 3 squared, which is 9, times -3 to the 3rd, which is -27. Okay? So at the moment, right now, this is multiplying to these three negative, because positive, 1458, right? Negative 1458, yeah, okay. Well, that's not right, right? Negative 1458 is way over here. My y-intercept is supposed to be here. First of all, the sign is wrong. So again, that's why the negative is going to have to appear there to fix that also. But then I also need a number here that will multiply times the 1458 and give me the correct size of 4. Well, fractions are perfect for that. If you want to have 4 and not have another size, you simply multiply by the one you want and divide by the one you don't. So right here, I'm going to multiply by 4 over negative 1458. And that's where this will come in handy over here. So to finish out my polynomial, I'm going to multiply by negative 4 over 1458. And of course I know you can reduce that, but the numbers are more poignant this way, right? So this actually reflects, as close as we can, without plugging in a bunch more points and doing a bunch more work, the polynomial that you see in front of you, right? It has all the correct factors, and then it actually will come out with the correct y-intercept because of the fraction in the front. Okay.